Hello dear students. So today we are going to discuss another topic in coordination chemistry, which is the most important part, that is nomenclature of coordination compounds. So nomenclature of coordination compound is very important to avoid the misconceptions about the naming of coordination compounds, particularly in case of isomers. So International Union of Pure and Applied Chemistry has done work in this regard and has given certain rules in order to name the coordination compounds so that all these rules can be followed all over. So in this case we will discuss the nomenclature of coordination compounds in detail. Okay. Under the IPEC nomenclature, so we will be first taking up the rules which are given for writing the formula of a complex. That means if the name of the complex is given, so how to write its formula, right? And there are certain rules. So we'll go through those one by one. So the first rule is the formula of the cation, whether it is simple or complex, right? Simple means simple ions and complex means that will have two different species which will be or which are non-ionizable, right? So then formula of the cation, whether simple or complex, is written first followed by that of anion. So this will be the first rule for writing the formula, right? We have to always write the cation first. For example, if we take the example of simple salt, that is sodium chloride, right? Everybody knows the formula of sodium chloride. So we are writing sodium first while writing its formula, so Na, right, because it is cation, and chloride means Cl. So NaCl is the formula of the species. In this species, cation comes first and then anions. Now let us take an example, that is sodium hexacyanoferrate 2. Now this is a coordination complex and its name is given. And as per rule, we have to write the formula for the species for this coordination compounds. So again, we have to stick to this rule. First of all, we will be predicting that which species is acting as cation and which species will be anion. So cation will be sodium. So we'll write Na for this species, then leave some space, then square bracket. Hexacyanoferrate. Now this is complex. Hexacyanoferrate. So first we'll be taking up this central metal atom, that is Fe. Ferrate stands for Fe. Cyano means Cn. And then how many times? Hexa stands for 6. So in this will be the coordination, but still its oxidation state is 2. That means central atom has 2 oxidation state, plus 2 is this, minus 6 is this. So what should be the number of sodium counter ion? It should be 4. So finally I can write, first of all I'll be writing Na 4 times because it's a cation, then followed by central atom, then ligands. So I'll get my coordination complex. So this is how we write the formula. So right now we will stick to this rule only, that cation has to be written first. So this sodium hexacyanoferrate can be written like this, Na4 FeCN6, and in this complex the cation and anions are mentioned, right? This sodium will act as cation and this is anion. Now if we go back to the general terms, so this is simple cation, whereas this is complex anion. So this anion in Na4 FeCN6 will act as anion. Okay. Now let us take another example. Triamine triaqua chromium 3 chloride. Now in this species, triamine triaqua. So amine is a ligand, triaqua is also ligand, chromium is the central atom, 3 is the oxidation state, and chloride is the counter ion. So as you can see that chloride is written on the right side, so that means this complex will be cationic. So we will write first this cation, right? You will come to know after going through all the rules that how to write this. So first of all, because complex is there, so complex has to be written within square brackets. Then we will focus on the central metal atom, so it's chromium, so I am going to write Cr. Then now triamine, amine is NH3. How many times? 3 times. Then triaqua, aqua stands for water. These are all the terms you have to learn. How many times? 3 times. And then square bracket close. So this will be our cation. Complex cation is there, followed by Cl. Now how many chlorides? That will be represented, that can be calculated from this oxidation state. So that means chromium has +3 oxidation state. Water is neutral, it will have 0. Ammonia is neutral, amine is neutral, so it will have 0. So in order to neutralize this +3, we will write Cl3, 3 counter ions. So this complex is cationic, whereas this one is anion. So cation has to be written first, followed by anion. So the formula for triamine, triaqua, chromium 3 chloride will be this one. So finally we can write it as Cr NH3 3 times, H2O 3 times, square bracket close, Cl3. So this one will be the final formula of the species. Okay, now we will go to the next species, this one. Now this is a complex in which both cations and anions are there, and both are in complex form. So first we will write this complex AgNH3 twice positive, and the counter the negative anion or anion will be AgCN twice negative. Okay, so cation and anion as per this first formula, first rule for the writing the formula of the complex. So cations are first written, followed by anions. I think this is clear to you. Now next one is second rule. It says that within the coordination sphere, now once we go into particular coordination sphere, the symbol of the central atom is written first, followed by the symbols or formulas of ligands in alphabetical order irrespective of the charge on them. So this is the second rule, right? What do we have to do? First of all, we will select a coordination sphere. For example, from this above example, we can take FeCN6. This is 4 negative, right? So whatever is the coordination sphere, whether it is cationic or anionic, how to write within coordination sphere. So the symbol of the central atom. So first of all, we will write, after beginning this square bracket, we will write the central metal atom, right? And after that, we will write the symbols of the ligands in alphabetical order. If there are more than one different ligands are there, for example in this complex, so we have written for this complex we have written, it was triamine, but first of all what we are going to write, we are writing the square bracket and then chromium. So I have written chromium, Cr, because central metal atom. After that triamine, so it is amine, so it starts with alpha. We have to follow the alphabetical order for writing the ligands irrespective of the charge, whether it is neutral or it's negative. So we'll write alphabetically. So it is triamine, so I'm going to write NH3 3 times, amine, NH3. And do remember, for ammonia we will write AMMINE while writing or treating it as ligand. So it is amine, NH3 3 times. Then triaqua. Now amine is there, so A is same in aqua and A. Then we will move to the next one. So so it's M. So M comes first. It's just like as we check the meanings or words in dictionary. So likewise, so then water is aqua 3 and then square bracket close. So this will be the order as per this second rule, that chromium, that is central metal atom. Then if there are more than one different ligands are there, so we will follow alphabetical order, whatever will be their name, not the symbols, alphabetical order. For example, this is amine, this is aqua. We won't follow that NH3, N is there or H is there, right? Irrespective of their charge. I hope this is clear to you. Now the example, another example is given here. So central metal atom is cobalt, so square bracket and then cobalt is written. Then for NH3, as we have written, AMMINE, and for chlorine we will write chlorido. This is the latest convention that IDO has to be added to the anionic ligand. So amine comes first, then A comes first, then C. So we'll write first amine, how many times, whatever is their number, and then square bracket is closed, and finally the counter ion is written. Ammonia, then chloride. In case we have polydentate ligands, so polydentate ligands are also listed alphabetically. While listing in alphabetical order, the first letter of the abbreviation of the ligand is used to determine their position. So we will write that what is the first letter of their name while writing the name of the species. For example, chloride is there, so chlorido, and then ethane 1, diamine. This En is ethane 1, 2 diamine, already discussed. So it is bidentate ligand. So its name starts with E and its name starts with C. So we will first write C, that is chloride is written, and then ethane 1, 2 diamine. So they are written as per the alphabetical order. So this was rule 2. Okay. Now the next rule, rule 3. The formula of the entire coordination sphere, very important, formula of the entire coordination sphere is enclosed in square brackets. This we have already discussed in case of complex species how to write. For example, K2 CuBr4 is there. So we have to write this complex in this format, that is K2 will be the counter ion, which is cation, and CuBr4 has to be written within square brackets. So this will be acting as anion, right? Next rule, fourth rule, is the formulae for polyatomic ligands, and the abbreviations used for ligands are enclosed in brackets or parentheses. For example, if there are polydentate ligands, so instead of writing their complete name, we can use certain abbreviations for them, and those abbreviations they are to be written within parentheses. For example, this is, what is this? Here it will be CH2, and at this point it will be again CH2. So it is CH2NH2, CH2NH2. What will be the name? It is ethane 1, 2 diamine. So instead of writing this ethane 1, 2 diamine while writing the formula, so we can write this instead of this. While naming, we will name it, but instead of writing this CH2, NH2, CH2, NH2, we will just simply write En, and it has to be enclosed within parentheses. Clear? Now another example, EDTA, that is ethylene diamine tetraacetate ion. So instead of writing this structure, its formula, we will simply write EDTA. So it is understood, but it has to be enclosed within brackets. For pyridine it will be PY instead of writing this structure. Okay. So this is rule number 4. Now fifth rule, it says within a coordination sphere, the metal atom as well as the ligands are listed without any space between them. This is quite simple, that there should not be any space. So they should be in continuation. Coordination sphere, metal atom, then there is no gap, then NH3 4 times, one ligand, then second water, so there is no gap, and third one is chloride. And then square bracket close, and outside it is counter ion. So it's simple that we will not leave any space between the while writing the formulas of central metal atom or ligands, whatever are present. Okay. Then the last rule: when the formula for a cationic or anionic coordination sphere is to be written without that of the counter ion, okay, means there is no counter ion, then the charge with the number before the sign is written as a right superscript outside the square brackets. This we are doing, right? So first we will be writing number, and then we will write the charge. For example, for cationic complex CONH36Cl3. So this is a neutral complex. In this case, the complex ion is cation. So if we remove these chlorides, so what will happen? This complex will acquire certain charge, and that charge will be CONH36. Then we will first write 3 and then positive. So this is the exact way, not plus 3, right? So avoid this and follow this, and 3 chloride ions are removed. For an ionic complex, so now that means K3 is cation and the complex will be anion. So while it is ionized or it get dissociated, so what will happen? K3 counter ion is removed and we will get anion as the complex. So you can see Cr, CN6 and then 3 negative. So we have to specify this charge on the species. Okay. So these were the rules for writing the formula of the species. Now let us practice some examples on the basis of rules that we have discussed. The first one is pentaamine nitrito and cobalt 3 ion. Okay, so how to write its formula? First of all, we have to check that whether the complex given to us is cationic complex or anionic complex, right? So it's in ionic form, ion is written. Whenever ion is written, so that means the counter ion is not mentioned, okay, or primary valency is not given to us. So then we will just write the complex, okay. So I'll start this writing this complex as square bracket. Then what was the first thing that we have to write? First of all, we'll be writing central atom. So central atom in this case is cobalt. So cobalt will be written CO. Is it clear? Then after that, followed by, after writing this metal atom, we will write the ligands in their alphabetical order. So there are 2 ligands, 2 types. That means this complex is heteroleptic. Pentaamine, penta means 5 times, amine is there. So I am going to write within parentheses, because whenever there are 2 elements in the complex, so we will write in parentheses how many times? 5 times. So NH3 amine is written 5 and within parentheses and 5 times, right? And then it's nitrito N. Now nitrito N, this is interesting factor, as if you remember that ambidentate ligands, so which have more than one element through which they can coordinate, right? So nitrito N stands for, means it is N double bond O, single or coordinate bond O, and it is going to coordinate through this nitrogen, okay, from this nitrogen, not through oxygen. So that's why N is written. So how I am going to write this? I'll write within parentheses simple NO2. How many times? 1 time. And then square bracket is closed. Now what? It's an ion. So this will be our complex. So it will be cationic complex. So what should be the charge? So how to calculate charge on this? We are given oxidation state of central atom, that is cobalt plus 3. And ammonia is neutral. Nitro is, or nitrito N is -1. So plus 3 is there and -1 is there. So how much charge is left? Unbalanced. So that is plus 2. So plus 2 charge will be there. So the complex formula will be CO NH3 5 times NO2 and 2 positive. This is the formula. Okay, I hope it is clear to you. Let us take another example. It's potassium tetracyanonickelate 2. So since potassium is given, so this shows that this complex will be having anionic coordination sphere, or it will be anionic complex. Okay, potassium is the counter ion. So we will write potassium, then followed by square bracket tetracyanonickelate. Now first of all, in square bracket we will be writing the central atom, which is nickel, Ni. Okay, tetracyano. Now cyano stands for ligand, that is Cn. How many times? Tetra stands for 4. Okay, nickelate. Nickelate is 8 is written when the complex coordination complex is anionic, right? Then we write the central metal atom followed by 8. Now how many potassium ions will be there? So central atom has oxidation state 2, that means nickel is in +2 oxidation state, and cyanide has -1 into 4, so straight away I can write -4. So 2 get cancelled out, so net charge comes out to be 2. So in order to neutralize that, we will write K2. So the formula of the species that can be written as K2 NiCN4. This will be the complex, right? Now the next example is hexaamine cobalt 3 sulfate. Now counter ion is to the right side, that means the complex will be cationic. How to write? Again, first of all we will write square bracket, we will select the central atom, that is cobalt. How many times? It is hexaamine, that is NH3 6 times, right? And then sulfate, so SO4 is sulfate. So we have to check that how, whether it will be 1 time, 2 time, 3 time. So the central atom has oxidation state +3. So for +3, amine is neutral, sulfate is -2. So -2, how can we neutralize this? So we'll be writing it as sulfate 3 times, which makes 6, in this species 2 times. I think now it will be clear that it comes out to be CO NH3 6 times, right? Whole twice, because cobalt has +3 oxidation state and sulfate carries -2, so it will be SO4 3 times. This will be the formula. Okay, we will discuss more about such complexes later on. Another example that can be selected, that is tetrahydroxozincate ion. Tetrahydroxozincate ion. Can you try it? Tetrahydroxozincate ion. Again, it is in ionic form. So tetrahydroxo, first of all zincate, so it will be Zn. Zincate. Tetrahydroxo. Tetra means 4 times. Hydroxo means OH. How many times? 4 times. Square bracket close. Then what should be the charge on this? Charge 2 is given, so +2. OH is single negative, so into 4 times, so it comes out to be 2 negative. right? So it's an anionic complex. So the final name can be written as, final formula can be written as Zn OH 4 times 2 negative. Okay, rest you can practice. Thank you.